Okay, so as you know that the branch of physics which deals with the study of motion of material objects is called mechanics, right? So in this chapter, some of the important topics is nothing but it is regarding the distance and displacement. Okay, so coming to the sum of the difference between distance and displacement, you can see there what is distance. Distance is nothing but the length of the actual path traveled by a particle, whereas displacement is nothing but it is the shortest length from the initial position to the final position. Okay, so displacement always depends upon the initial and final position of the particle. Okay, so the next difference is said as distance traveled by a particle is always positive. Okay, so as you know that distance is always positive because it depends upon the actual path traveled, but here the displacement can be positive, negative or zero. Okay, so next, distance is a scalar quantity whereas the displacement is a vector quantity. So next is nothing but distance traveled by a particle depends upon the shape of the path followed by the particle, whereas the displacement of the particle does not depend upon the shape of the path followed by the particle. Okay, so as you know that if I say that a particle travels in this shape, okay, so how you are going to calculate the distance? You need to calculate what is the path traveled by the particle or the person completely. Okay, so when I talk about the displacement, this is my initial point and this is my final point. Okay, only this two we are calculating. We doesn't I mean the displacement doesn't depend upon the shape of the path followed by the particle. Okay, so this is the difference between the distance and displacement. Okay, so next is nothing but they have given that in the motion of straight line chapter you don't have speed and velocity. Okay, speed and velocity is not there, so let us not go through that. So coming to this acceleration, as you know that what is acceleration? Acceleration is nothing but it is the rate of change of velocity with time is called as the acceleration, correct? So coming to the next is nothing but it is displacement time graph. So just you can go through that, and even the velocity time graph you can go through. Similarly, displacement of a particle in a given interval of time is equal to the area under the velocity time graph. So even this you can go through. Anyhow, the position time graph is not there. Okay, it has been removed from the syllabus. So you have this velocity time graph. Okay, you have this velocity time graph for different cases. Okay, so which is the first one you can see there. So in the velocity time graph you can go through. So as I said in your examination, so any one or two can be asked from these graphs. Okay, they'll ask draw a velocity time graph for either it can be an increasing velocity or decreasing velocity, something like that. Okay, so they can ask different cases. You can just go through the different cases here. Okay, which is that first case it says. So first case is nothing but it is regarding the velocity time graph for a body traveling with uniform velocity. Okay, so whenever we say that, yeah, it is a uniform velocity, that is the body is moving with uniform velocity, the acceleration comes out to be zero. Okay, because acceleration depends upon the rate of change of velocity. Since we have said that the body is moving with zero velocity, so hence the graph comes out to be a straight line parallel to the x-axis. Okay, that is the first graph. Second graph is nothing but you can see there a body which is starting from the rest. Okay, the body which is starting from the rest and moving with positive acceleration. Exactly. Okay, so the third one is nothing but where a body is starting with some initial velocity, not from the origin. At the initial time itself, I mean in the starting itself, it has some initial acceleration, sorry, initial velocity. Okay, so that is regarding the third figure there. Next one is fourth is nothing but where a body moving with a negative acceleration. Okay. So the next fifth figure says that it is regarding for a body which is moving with increasing acceleration. Okay. Next graph is nothing but it is regarding for a body moving with decreasing acceleration. Okay. So the last point is nothing but when a body thrown vertically upward moves under the gravity. Okay, whenever a body is thrown vertically upward, so that is what the velocity time graph it shows there. Okay, so these are nothing but the some of the important cases which we come across. Okay, so the next is nothing but it is a very important derivation, that is kinematic equations. Okay, as you know that we have three kinematic equations. uh, the first one is nothing but which is v is equal to u plus at. Okay, this is the first equation, right? So let us go through that. See, what we have done is we have just taken a velocity time graph. Okay, we have taken a velocity time graph for a positive constant acceleration. Okay, so what we have done is we have just considered let u be the initial velocity of the particle at time t is equal to 0. So at time t is equal to 0 itself, you can see that the body has some initial velocity. Okay, and we are going to say that that initial velocity is denoted by u and the final velocity is taken to be as v. You can see in the figure there. Okay, now what we are going to do is we will consider 2 points on this line. Okay, so one is nothing but the point A which is at time t is equal to 0 and another point at B at time t is equal to t. Okay, so now what we are going to do is, as we know that we are going to draw BD perpendicular to time axis, BD perpendicular on time axis. Also we are going to draw AC perpendicular on BD. Okay, where AC is perpendicular to BD. So now OA is nothing but equal to CD. In the figure you can see OA is nothing but equal to CD, which is taken as U. Okay, so next BC is nothing but what? If this is, if this completely from here to here it is V. Okay, we are consider this as V till here. So if we take this one as U, so obviously the distance from here to here it will be V minus U. Correct. So hence what we are going to do is we will consider that BC as V minus U and OD is nothing but equal to T. So now from this triangle what we are going to do is in this triangle ABC we will consider the value of tan theta. Okay, we will consider this value of tan theta. So tan theta is nothing but what is equal to BC by AC. Okay, so BC value is nothing but what, V minus U, whereas AC is nothing but equal to OD, that is AC is equal to OD. Okay, so the slope of this velocity time graph gives the acceleration. Okay, so the slope of the velocity time graph gives the acceleration. So hence A is nothing but equal to what is BC, BC is nothing but V minus U, what is OD, OD is nothing but equal to T. So hence you can write V minus U is equal to T, or it can be written as V is equal to U plus AT. So this is regarding the first equation. Okay, first kinematic equation. Okay, so in the second, it is nothing but it is said that we need to calculate what is the distance traveled in a time interval t. Okay, as you know that the body starts traveling from point A to point B, right? You need to calculate what is the distance. For that, we are going to take, as you know that the displacement, the distance traveled by a particle is nothing but equal to velocity time graph. Okay, the distance traveled by a particle is nothing but that is equal to area under the velocity time graph. So you can take the area under the velocity time graph, that is nothing but equal to OABCD. Okay, OABCD. So now this OABCD is nothing but it is a trapezium. Okay, so hence the displacement S, we are going to consider S as the displacement. Okay, so S is equal to area of the trapezium, that is nothing but equal to OABCD. Okay, So next, this trapezium has been divided into rectangle plus triangle. So what we are going to do is we are going to express that area of trapezium as in other way, that is area of rectangle OACD plus area of triangle ABC. Okay. So next is S is equal to, what is that, area of the rectangle is nothing but area length into breadth, that is U into T. Okay. Next, plus area of the triangle is nothing but half into length into breadth. So half into T into V minus U. Okay. So that can be written as S is equal to UT plus half T into AT, that is UT plus half AT square. Okay. So this is regarding the second kinematic equation. Okay. So the next is nothing but the last one, velocity attained after traveling a distance. Yes. Okay, you need to calculate the V value. Okay, velocity. So now, as we know that the same thing we are going to take area of the trapezium we are going to take, and we are going to express that one as in terms of rectangle plus triangle. So the first step remains the same, that is S is equal to UT plus half into T into V minus U. So now what we are going to do here is we are going to take the value of A as we know that A is equal to what, V minus U divided by T, right? So now the T can be written as T is equal to V minus U divided by A. So hence what we are going to do is wherever we have T in this equation, we are going to substitute the value of T as V minus U divided by A. So substituting that, you are going to get this equation here. Okay. So next what we are going to do is we have taken that V minus U by A as common, and the left out thing will be U plus half into V minus U. So rest of the things are mathematics, which can be written as AS is equal to V minus U into 2U plus V minus U divided by 2. So 2AS is equal to V minus U into V plus U. So therefore 2AS is equal to V square minus U square. So this is regarding the kinematic equations of motions. Okay, which is very important. So where anyone can be asked for 5 marks. Okay. So just go through once. In case if you have any steps in the mathematical steps, you can ask. Yes, any doubts? Okay, fine. So next, coming to this relative velocity, as I said, this relative velocity, if they ask definition, it will be for 1 marks, or else it can be asked for 2 marks also, okay, with these units, or for 3 marks also. So that is 1 mark for definition of relative velocity, and 2 marks is for graph for different cases. Okay, so let us see what is this relative velocity means. When two objects move in the same straight line, we compare their motion in terms of relative velocity. So relative velocity means velocity of one object with respect to the other object. Okay, so as you know that when the two bodies are moving with the same direction, okay, we are going to express the velocity of body A with respect to velocity as body B as VAB is equal to VA minus VB. Similarly, velocity of B with respect to A as VBA is equal to VB minus VA. So this is the case where when the two objects are moving in the same direction. Okay, so let us take when the two bodies are moving in opposite directions. So the relative velocity is expressed as VAB is equal to VA minus of minus B, so that comes out to be as VA plus VB. Okay, so these are some of the different cases. Okay, so where you can see the first case is nothing but it is a position time graph of two objects with equal velocities. Okay, where the two objects are moving with equal velocities in the same direction. Okay, and the next is nothing but you can see there it is a position time graph of two objects with unequal velocities showing the time of meeting. Okay, so where you can see there are two objects, so one object moves with lesser velocity whereas another moves with the greater velocity, that is the unequal velocity we say. Okay, so at some point both the objects at meet at some point, and that point is nothing but that graph is denoted in figure B there. And the third one is it is a position time graph of two objects with velocities in opposite directions showing the time of meeting. Okay, so position time graphs of two objects with velocities in opposite directions. Okay, so these are some of the graphs. Okay, fine. Ganashri sir, when it will be zero and non-zero velocity. Okay, so here if two bodies are moving in the same direction at the same velocity, then the relative velocity will be zero. Okay, so if the two objects or the two bodies are moving in the same direction along the same along the same direction at the same speed, so the relative velocity is said to be zero. Okay, and non-zero you can guess by yourself. Okay, fine. Noor Fatima, yeah, correct. I just forgot to send the answer. Okay, fine. I'll do one thing. So after the class, do one thing. Just message me. Okay, just remind me. I'll just send you the answer for that two questions which I said in the last class. That is one is that is alpha is equal to 1 by t, and one is nothing but regarding that Young's modulus, I think. Okay. Okay. So this is regarding the motion in a straight line chapter. Okay, so coming to this mechanical properties of solids, see some of the definitions, that is defined stress, defined strain. So these things has to be studied by yourself. Okay, similarly these types of stress, in the types of stress you have normal stress, tensile stress, compressive stress, you have tangential, you have hydraulic. Okay, so this is some of the basic definitions, you itself just go through. Similarly you have strain, different types of strain, that is longitudinal, volume, shear. Okay, so I'll start with this about Hooke's law. Okay, what is Hooke's law? Where the stress is directly proportional to the strain, okay, within the elastic limit. So stress by strain is nothing but equal to constant. We can write mathematically stress by strain is equal to constant. Okay, so this Hooke's law is important. Coming to the next, there is nothing but um stress strain graph. Okay, even this is a very important thing. That is nothing but, as you know, that when you plot the stress strain graph, so it is nothing but which represents the elasticity of a body. Okay, so when you take a wire where one end of the wire has been fixed to a rigid support, whereas the another end of the wire has been connected to a load. So initially when you put some small amount of load, what happens, the wire stretches for some extent. So when you remove that load, so wire regains its original shape. Okay, so that is called as elastic. uh, that is represented by the curve OA. Sorry, not the curve, it is a straight line, that is OA. Okay, so that straight line denotes that where stress is directly proportional to strain. So the next thing is, when you increase the load compared to the previous case, so what happens at that point, the stress will be no more proportional to the strain. Okay, so you can see the point AB there. Okay, so the stress and strain will not be proportional. So next, when you increase the load again, so what happens, you can see there the value of strain is more. Okay, the value of strain is more. So what happens there is, just we are going beyond the elastic limit. So what happens there is, once you remove the load, so what happens, the body doesn't regains its shape in the same way as in the previous case. The body regains its shape in the some other way. Okay, so that is nothing but uh, regarding that point C there. Okay, next, if you increase the load again compared to the previous case, so what happens, there will be a plastic behavior. That is nothing but the wire get deformed. Okay, so it will be not able to regain its it doesn't it, I mean it will be not able to go to its initial shape. Okay, so that itself is called as plastic behavior, we call. So again, if you increase the load compared to the previous case, so what happens, there will be a some point where the body can withstand. So if you increase the load beyond that, so what happens, the wire breaks, and that is called as breaking point. Okay, so this is regarding the stress strain graph. So just go through about this different types of modulus, Young's modulus, bulk modulus, and rigidity modulus. Okay, it's very simple thing, these things, so just you can go through by yourself. So you have the test, physics test at 10 o'clock, right? So Monday at 10 o'clock you have physics test, correct? Yeah, you have at 10. So as you know that the instructions has been the madam has been sent the instruction, right? Shilpa madam has sent the instruction, that is chemistry madam. So I think you are aware of that instructions. So just write down the test in a clean A4 size sheet. Okay, so it should contain your name, your class, section. Okay, so that should be there. After once you complete uh, the test. Okay, let me tell how the uh, test is conducted. Okay, so the test is just at the time of 10 o'clock. Okay, I mean on Monday at 10 o'clock I'm just going to post the paper. I'm just going to forward the paper in the WhatsApp group. Okay, you have the class WhatsApp group, right? So I'm just going to uh, forward the question paper. So once the question paper is been forwarded, you need to start writing the answers. You need to answer. Okay, so once the uh, time is completed, that is at 10:40, 40 minutes has been allotted, duration is 40 minutes. So at the time of 10:40 uh, you need to complete everything. So 5 minutes, maximum 5 minutes will be given for sending the papers. Okay, how we are going to send is, you are going to scan the paper. Okay, then you are going to convert it into PDF, then you are going to send it to uh, do one thing, you just send it to the mail. Okay, so the mail IDs, I think madam has sent, right? So individual lecturers mail IDs has been sent. So just go through my mail ID. Okay, in case if you want, I'll just let you once again. So just just forward the papers to the mail ID. Okay, so maximum of 5 minutes will be given. Okay, maximum by 10:45 your paper should be sent to the email ID. So later if you send, your papers will be not corrected. Okay, anything else to be asked? Any doubts? Send your answers in send your answer scripts to email ID. I'll just send the email ID once we conclude today's class. Okay, yeah, that is what I'm going to send the email ID. Don't worry, I'm going to send the email ID. I'll just forward it in the group, so you can just forward your papers to the mail ID. Okay, yeah, no need of writing the questions. Okay, so just put the question number properly, just start writing the answer for that corresponding question. No need of writing the question. Okay, so for derivations and all, in case if there is a figure, figure is a must and should. Okay, so go through the numericals. Okay, in case if you have previous year question papers, so just go through the numericals in that. Okay, so just you'll get an idea, and even you can go through the numericals which we have discussed in the class itself. Okay, anything else to be asked? Who is this Tejas? Why you don't know to mail the answer scripts, man? It's very easy, no, man. Ask your any one of your friend. He'll teach you how to send. Okay, so before sending, okay, please make a practice of that. Okay, just scan any of the sheet for sample. Just scan any of the document. Okay, so convert that into PDF, then send to your email ID itself, so it will be easy to you once you are done with the examination, I mean the test, and it will be easy for you to send to our respective email IDs. Okay, okay, fine. uh, Anything else to be asked? Okay, students, uh, we have just gone through, I mean we have just briefed some of the important topics. Okay, as I said, just if you want to score out of out, go through the entire chapter. Okay, so and one more thing, as I said in the previous class itself, I don't want any failures in physics. Okay, any help or anything regarding the subject you can ask. Okay, but I don't want any failures in my subject. Okay, so with this thing I'll just conclude today's class. All the best, students, for your test. Write well. Okay.